This is Joe at Sierra Specialty Auto. Welcome back to the shop for part 2 of the Reamer holder construction project. We'll get right over to the roll-around cart and get started on finishing up this project. Well, one of the potential pitfalls in designing a project like this in your mind rather than on paper is the possibility that you'll overlook some important detail. As I started trial fitting this, as soon as I put the first through bolt through this hole, I had that aha moment, that slap your forehead moment. It's going to be hard to get the taper drift in there, and the Morse taper tang gets blocked by the cross bolt. So I need to remachine for dog point retaining bolts that will stop short of the opening on each side, and I need to machine a couple of windows in the outer adapter to allow the drift to pass through. So let's go to the milling machine and start on that, get set back up into the super spacer. I've already picked up these two cross holes, taken them, took the 5/16 tapped hole out to 5/16 and tapped both of these holes 3/8 16. Now I'm ready to center drill and drill 3/8 at 90 degrees for the drift slot. I'll drill this to 3/8 and then put a 3/8 end mill in and traverse about 7/16 of an inch, I believe, and that should give me a 1 inch, just under a 1 inch slot, 15/16 slot to match up with the slot in the R8 adapter. I'm going to reset the camera and show this tree collet system. Most of you guys are probably familiar with Bridgeports and similar mills that have drawbars, R8 spindle and drawbars. This is a Tree 2 UVR, and it has a different, completely different collet mechanism. This is often referred to as a horseshoe on a tree mill. Just a horseshoe-shaped locking ring that rides in slots here. We pull this out, pull the spindle down, and you saw it released the drill. Now I put the end mill in here to the desired depth. Don't want to go too deep because I have to clear the chuck. Run up on the spindle, and the locking collar pulls the collet in. It uses a collet like this. This is a Z double taper collet. Now let's get back down to the work. I have to be careful here to make sure that the collet locking ring misses the chuck jaw, and it does. I'm about a 1/16 of an inch clear, so I can come on down, lock the spindle, take a quick look, make sure everything looks good. Let's get some coolant going here. I'll turn the volume down on this in edit, but be advised there's compressed air coming here. There's one slot done. I need to make a pair of approximately 3/4 inch long dog point retaining bolts now to hold that center part of the adapter, the R8 shank in the big end of the MT3 to MT4. So I've run a dot on here. This is a little bit too long and it needs a few thousandths taken off yet. First I'm going to center drill so that after I get it cut to length I can chuck up right at the head and have the other end in a live center to take off the threads for about a 1/2 inch. I need to run that down to 5/16 or actually 0.310 to match the other bolt. That's enough for the live center to pick up. Get that changed out and reset that bolt. I'll leave the nut on here so that when it comes off it'll give me a start on cleaning up the threads. I'll just run it up snug and rechuck just on the head of the bolt, just on the first notches on the chuck, so it can find its own center when I bring the live center up. I need to make room for the carriage, so I'll run the tailstock a little farther out, cinch up just snugly on here, and then put a little pressure on the tailstock and get that live center in tight. Lock that up, and now we should be turning fairly true. Yes, that looks fairly good. Now we take this down to 310, approximately 310. let's get a look at that and see where we are. 320. So we want about 10 more off. That looks pretty good. I'll take that nut off and dress the ragged end of that thread with the file. Do that one more time and we'll have our pair of retainer bolts. Well, let's try one more time to see if this will go back together according to plan, or go together according to plan. I've cut windows for the taper drift to pass through, and we've machined dog point retaining bolts, so maybe I'll have better luck this time. There's the holes lined up fairly well. Let's see if we can sneak this in. Looks like we need to wiggle this over a little. I think it turned a bit as the adapter went in. There's one in. Two in. Now let's see if the rear cross bolt will go. And it did. All right, cinch them up. And we have see if I can get this to show. I don't know how well this is showing on camera, but we have free motion, maybe a couple of degrees. I can push it back and forth a little bit. Now, put a taper shank drill in there and we can see the tang coming down. Bottom that into the slot, and I can feed the taper drift in and knock it out. That all works pretty well. Let's go put it in the lathe and see if it'll ream a straight hole. One of the first things I'm curious about is how much of my lathe length I lose by using this. I don't really see it being a huge issue. Almost all the time I'm up within 6 or 8 inches of the chuck. So on a 36-inch, a 40-inch lathe bed, if I lose 6, 7 inches, it shouldn't be a big deal. So, but let's find out. This 3/4 inch reamer sticks out 7.5 from the face of the tailstock, from the quill. So let's put this in here. Give it a little tap with a dead blow hammer to seat everything. And now we're measuring, so we were 7 1/4. Have to use an 18-inch scale for this. Now we're 14 1/4. So I'm losing 7 inches for my reamer holder. And I'm not really concerned about that. This is a piece of 360 alloy brass tube, 16th wall nominal, actually more like .065, 3/4 ID and 7/8 OD nominal, but since the wall thickness is a little more than a 16th, it's probably 6 or 7 thousandths under 3/4, and I want to make it 3/4 or a little under. I want to leave room to hone out to actual OD of .752. So I have dosed this up. I've squirted some Cool Tool tapping fluid, tapping and reaming fluid in there. I've got the lathe set at 108 RPM. I like to ream slowly. I'm going to go in here a little over 4 inches. That'll be about 2 inches longer than the flute length on the reamer. So that should give me a picture of what happens at the back end of the flutes. In the past, I've had scoring in the area behind the flute at full penetration. I've had scoring that sometimes does not hone out completely at .752. So we'll see how this goes. That sounded good and felt good. I'm going to shine my light in here and see if I can see any scoring. And I don't. I see what looks like a reasonably good reamed finish in brass. It's never perfect, but there are no obvious defects and it feels smooth. So I'm pretty sure that's going to hone out nicely with just a couple thousandths. And now here's my Brown & Sharp Intra mic, internal 3-point micrometer. I'll get an accurate reading with this within 2/10 of an inch for diameter, and I want to compare the diameter at the mouth of the bore here with the diameter at the full reach of the tool. That's somewhere in the neighborhood of a little over 3 inches, I guess, right at 3 inches, maybe 3 1/8. And I'm hoping to get the same number. I have, in addition to scoring at the outboard end, I have also had issues with bell mouth, with the reamer held securely in the tailstock, cutting a little bigger at the outboard end than at the far end. So right here I'm measuring 750 and 2/10. Go all the way in. I'm 750 and 2/10. That's fantastic. That is exactly the same dimension at the farthest end of the reach of the flute and where the flute has been clear of the bore for an inch or so That's perfect. That's exactly what I was hoping for. This floating reamer holder. This floating reamer holder is going to be a very handy tool, and I wish I had done this 25 years ago when I first started my brake cylinder business. I would have been able to use this every day, and it would have been a real benefit. I just day late and a dollar short, but I'm going to enjoy it from now on, even though I'll use it a fraction of the time that I would have been able to use it when I was in business. That didn't go perfectly, but all in all, not too bad. One hole in the wrong place, one significant change of the mental plan in the middle of the project, but it came out all right. It came out better than all right. It came out exactly what I wanted, and it worked exactly how I wanted, and I'm real happy to have this tool in my toolbox. I hope you enjoyed this, got an idea of your own maybe, or maybe you have an idea for an improvement on what I did. If so, I hope you'll comment, I hope you'll subscribe, and I hope you'll come back to the shop again for another visit sometime. Thanks for watching.